Hello my Linians, this is Teacher Sarah, and today we are going to discuss solving exponential equation and inequalities. This video tutorial is based on your learning activity sheets in General Mathematics, Quarter 1, Week 6. So bring out your learning activity sheets and turn your learner's module to pages 83 to 98. Our learning targets are solve exponential equations and inequalities, represent an exponential function through its table of values, graph, and equation, find the domain and range of an exponential function, and determine the intercepts, zeros, and asymptotes of an exponential function. Before the lesson, let us have some warm-up questions. I have some questions for you to answer. Question number 1. Simplify a to the third power b to the fourth power c raised to negative 3 over abc. Times starts now. The answer is a to the second power, b to the third power over c to the fourth power. Second question. Which of the following is an exponential function? Times starts now. The correct answer is letter A. F of x equals 2 raised to the second power. To start with our lesson in solving exponential equation and inequalities, let us first recall the following definition of theorems. So you let A not equal to 0, so we define the following, that a raised to 0 is equal to 1, or any variable or number raised to 0 that is equivalent to 1. So if a raised to negative n equals 1 over a raised to n. So to simplify, your negative exponent becomes the denominator and then the exponent becomes positive. Then for the following, you let x and y be rational numbers. So we have a raised to x times a raised to y equals a raised to x plus y, considering that x and y are exponents. So if the bases are the same, you add their exponent. Then we have a raised to x over a raised to y, same bases. So you subtract their exponent, a raised to x minus y. Then for a raised to x raised to y, so that is equal to a raised to x times y. So you are going to multiply their exponent. A times b raised to x, so your x is distributed in the factors a and b. So we have a raised to x times b raised to x. Then for a over b raised to x equals a raised to x over b raised to x. So you distribute the exponent x in the given fraction. Some exponential function may be solved by using the fact that exponential functions are one-to-one. So one-to-one property of exponential functions, we have if x sub 1 not equal to x sub 2, then b raised to x sub 1 is not equal to b raised to x sub 2. Conversely, if b raised to x sub 1 equals b raised to x sub 2, then x sub 1 equals x sub 2. Example, solve the exponential equation 4 raised to x minus 1 equals 16. So as you observe, the bases are not the same. So you make your bases equal before you solve for the unknown variable. So write both sides with 4 as the base. So we have 4 raised to x minus 1 equals 4 to the second power, since 16 is a factor of 4 to the second power. Then, applying one-to-one property of exponential function, so the bases are equal, therefore, you can equate also that their exponent are equal. So we have x minus 1 equals 2, then solve equation in one variable, applying the addition property of equality or the shortcut method by transposition method. You just transpose -1 to the right side. The sign will change from negative to positive. So it becomes x equals 2 plus 3, or therefore x is equal to 3. So you can check also to find out if your answer or your calculated value for x is correct. Just replace the value or the computed x in the original equation. So if our original equation is 4 raised to x minus 1 equals 16, so it becomes 4 raised to 3 minus 1 equals 16. So 4 raised to 3 minus 1 is 2 equals 16, or 4 to the second power equals 16. So therefore, the members of the equation becomes equal. Both are equal to 16, therefore, it means that your calculated value for x as 3 is correct. Okay, there is an alternative solution in the same exponential equation. So for 4 raised to x minus 1 equals 16, you write both sides with 2 as the base to make their bases equal. So we have 2 to the second power multiplied by quantity x minus 1 equals 2 to the fourth power as a factor of 16. So we can equate their exponent since the bases are the same, applying the one-to-one property of exponential function. Then we have 2 multiplied by quantity x minus 1 equals 4. Then using the distributive property, we have to distribute 2 in quantity x minus 1, so it becomes 2x minus 2 equals 4. Then combining the constant, you transpose -2 to the right side, so it becomes 2x equals 4 plus 2, so 2x equals 6. Applying or dividing both sides by the numerical coefficient of x as 2, therefore x is equal to 3. Again, you do the checking. For example number 2, you solve the equation 125 raised to x minus 1 equals 25 raised to x plus 3. Since they do not have the same bases, we have to rewrite. So they have common bases as 5 raised to the third power times quantity x minus 1 equals 5 to the second power times quantity x plus 3. So they have now the same bases, so you can equate that their exponent are equal. So by distributive property, you distribute 3 in quantity x minus 1 and 2 in quantity x plus 3. So we have 5 raised to 3x minus 3 equals 5 raised to 2x plus 3. Then equate that their exponent are equal. Then by combining like terms, solve for the value of x. So by transposition, you combine 2x to 3x so that it becomes negative in sign, and then you transpose negative 3 to the right side so that the sign will change from negative to positive 3. So therefore 3x minus 2x is equal to x, and equals 6 plus 3 is 9. Therefore x equals 9. For example 3, you solve the equation 9 raised to x squared equals 3 raised to x plus 3. So you make your bases equal. So 9 has a factor of 3 squared. So becomes 3 raised to 2x to the second power equals 3 raised to x plus 3. Then you equate that their exponents are equal since the bases are equal, applying one-to-one property of exponential function. Then write in standard form. So 2x squared minus x minus 3 equals 0. Then by factoring, you find a factor of the given trinomial, and the factors are quantity 2x minus 3 times quantity x plus 1, then equate to 0. So its factor equate to 0. So for 2x minus 3 equals 0, x equals 3 over 2, and for x plus 1 equal to 0, x equals negative 1. So the value of x, there are two roots since it is in the second degree. So to check, to find out if your answer is correct, use a value of x one at a time. For example, so using the original equation, if you want to use 3 over 2 for x, just replace 3 over 2 for all x in the given equation. And then if you use x equals to negative 1, so you replace negative 1 to all variable x in the given equation. If the members of the equation becomes equal, that means your calculated value for the variable x is correct. So remember, you can use value of x1 at a time to check your answer. So in solving exponential inequalities, we also have a property of exponential inequalities. If b greater than 1, then the exponential function y equals b raised to x is increasing for all x. This means that b raised to x less than b raised to y if and only if x is less than y. So if 0 less than b less than 1, then the exponential function y equals b raised to x is decreasing for all x. This means that b raised to x greater than b raised to y if and only if x is less than y. Example, you solve the exponential inequality 3 raised to x less than 9 raised to x minus 2. So both 9 and 3 can be written using 3 as the base. So we have 3 raised to x less than 3 to the second power multiplied by x minus 2. So 3 to the second power is a factor of 9 to make their bases the same. So applying the one-to-one property of exponential function, if the bases are the same, you may equate that their exponents are the same also, or equal. So 3 raised to x less than 3 raised to 2x minus 4. So since the base 3 is greater than 1, then the inequality is equivalent to x less than 2x minus 4. Or you transpose 4 to the left, negative 4 to the left, that becomes positive. So positive 4 less than 2x minus x. The direction of the inequality is retained. It is still less than because the base 3 is greater than 1. So 4 is less than x. So the solution set to the inequality is x is an element of real numbers such that x is greater than 4. Another example of exponential inequality, 1 over 10 raised to x plus 5 greater than or equal to 1 over 100 raised to 3x. Since 1 over 100 equals 1 over 10 raised to the second power, then we write both sides of inequality with 1 over 10 as the base. So same bases, we equate that their exponent are equal by applying one-to-one property of exponential function. But before that, you need to distribute 2 to 3x so that it becomes 1 over 10 raised to x plus 5 greater than or equal to 1 over 10 raised to 3x. Since the base 1 over 10 less than 1, then this inequality is equivalent to x plus 5 less than or equal to 6x. So the direction of the inequality is reversed. Instead of using greater than or equal, we reverse the inequality symbol into less than or equal because the base 1 over 10 is less than 1. Then 5 is less than or equal to 6x minus 6. Continue simplifying. 5 is less than or equal to 5x by dividing both sides by 5. So 1 is less than or equal to x. So same procedure to check your answer, by just replacing the value of x in the original exponential inequality. So therefore, the solution set is the value of x is an element of real numbers such that x is greater than or equal to 1. And to graph exponential function, so the graph of an exponential function is necessary tool in determining its behavior and characteristics, its intercepts, asymptotes, and zeros. A graph can also provide insights as to real-life situations that can be modeled by exponential function. So in the following examples, the graph is obtained by first plotting a few points. Results will be generalized later on. So from the given example, sketch the graph of f of x equals 2 raised to x. The value of b or the base is 2. So b is greater than 1. So for the solution, you first construct a table of values to identify the ordered pair for the given function, and then you graph. So the table of values for f of x equals 2 raised to x is as follows. The assigned value for x, we have negative 4, negative 3, negative 2, negative 1, up to 3. And these are the computed value for f of x or y. If f of x is negative 4, y is 1 over 16, and so on and so forth. And then to graph the points, you may use the following ordered pair: negative 4, 1 over 16, negative 3, 1 over 8, negative 2, 1 over 4, negative 1, 1 half, 0, 1, 1, 2, 2, 4, and 3, and 8. So, when you graph the points, so it looks like this. So, these are the points of f of x equals 2 raised to x. And then, when you connect them using a smooth curve, so it can be observed that the function is defined for all values of x is strictly increasing and attains only positive y values. As x decreases without bound, the function approaches 0. That is, the line y equals 0 is a horizontal asymptote. So, as x increases, y also increases in the form of f of x equals 2 raised to x. Another, g of x equals 1/2 raised to x. So, this time, the base is less than 1 but greater than 0. So, the base there is 1/2. So, again, these are the corresponding values of g of x, wherein the x are negative 2, negative 1, 0, and so on. So, the graph is shown. Then, when you connect the points, it can be observed that the function is defined for all values of x is strictly decreasing and attains only positive values. As x increases without bound, the function approaches 0. That is, the line y equals 0 is a horizontal asymptote. So, in general, depending on whether b greater than 0 or 0 less than b less than 1, the graph of f of x equals b raised to x has the following behavior. Yan, look on the graph. So, if b greater than 1, the graph is increasing to the right, while if 0 less than b less than 1, the graph is on the left. So, the following properties of f of x equals b raised to x, where b greater than 0 and b not equal to 1 can be observed from the graph. So, the domain is the set of real numbers. As you observe in the table of values, so the table of values for x, the assigned value for x, we have a set of integers such as negative, positive, and 0. So, that means that the domain is the set of all real numbers. And the range is the set of 0 and positive infinity. So, or set of positive real numbers for the range or y. Then it is one-to-one function because when you use the horizontal line test, it satisfies. So, there is only one point that will intersect the line. Therefore, the function is one-to-one. Then, the y-intercept is 1 and there is no x-intercept. The horizontal asymptote is the line y equals 0 or the x-axis, and there is no vertical asymptote. Okay, let us compare the graph, the behavior of the graph given the function f of x equals 3 raised to x and g of x equals 4 raised to x. So in the same coordinate plane, let's plot the points and observe the graph. Then indicate the domain, range, y-intercept, and horizontal asymptote. Okay. So for both this function, the base is greater than 1. So the bases are 3 and 4 for f of x and g of x respectively. Thus, both functions are increasing. The following table of values will help complete the sketch. So with the use of assigned value for x, then you solve for f of x and g of x. So observe the value. So these are the values computed given the assigned value of x. So your x, as you increase the value of x based on the table, f of x increases. Also g of x increases. So study the behavior of the graph. So the graph of g of x is this smooth curve closer to y-axis, while f of x, this is the smooth curve far away from the y-axis. So observe and compare the two graphs. Okay, for both function, the domain are set of all real numbers. The range are set of all positive real numbers. The y-intercept is 1 and there is no x-intercept. Horizontal asymptote or y equals 0. Then the two graphs have the same domain, range, y-intercept, and horizontal asymptote. However, the graph of g of x equals 4 raised to x rises faster than does g of x equals 3 raised to x as x increases and is closer to the x-axis if x is less than 0. So the higher the value of b, the closer it is in the y-axis. Okay, for g of x equals 4 raised to negative x, the function g of x equals 4 raised to negative x can be written also as g of x equals 1 over 4 raised to x. So this is an exponential function with base b less than 1. Thus, the function is decreasing. The following table of values will help complete the sketch. So this is the table of values for x and y and also the graph. The graph is decreasing, to the left. So the domain are set of all real numbers, the same. The range is also the set of all real numbers. Y-intercept is 1. There is no x-intercept. The horizontal asymptote is equal to 0. So as you observe in the graph, if the exponential function is in the form of y equals b raised to x, where b b is greater than 0 but not equal to 1, and b is less than 1, the domain and the range are set of, for the domain, set of real numbers, and for the range, set of all positive real numbers. And in observing the y-intercept, the y-intercept is 1 and the horizontal asymptote is 0. So in y equals b raised to x, the point is 0, 1. X is 0 and y is 1, for the y-intercept is 1. Okay, now this is your task. Open your activity sheets. In enrichment activity 1, and then you answer the following. So for enrichment 1, you complete the table. So you are going to copy the table in your answer sheet to give your answer. That is only for enrichment activity 1, number 1, no? And then enrichment activity 2, you solve for x. You are required to show solution on your answer sheet. Its item is 5 points. For activity or enrichment activity 3, you show your solution on your answer sheet, 10 points each. So first, you construct a table of values for the given function. There are 3 given functions. Then you make a table of values of x and y given, or there are assigned values for x. Then identify the ordered pair, plot the points in the Cartesian plane, and then connect the points in a smooth curve. Then describe the behavior of the graph. And for wrap-up activity, you are also required to answer the following questions to give you additional points. For each item, I'll give you 5 points. So this is your bonus point that should be added to your score in enrichment activity. I hope you learned something today. If you have questions or clarifications regarding the topic we discussed, feel free to contact your subject teacher through text, call, or post your questions in your official Facebook group or page. Thank you for watching. Don't forget to like and subscribe. Bye!